So I'm very excited to get to introduce our keynote speaker, Rob Gould. But first, I want to mention that we will have time at the end for questions. So throughout the talk, if you have a question, type it into the box, and then I will ask Rob those questions at the end. All right, so now it is wonderful to have Rob talk to us today over the interwebs. Rob teaches statistics at UCLA and is the founding editor of the journal Technology Innovations and Statistics Education. He's the creator of the very popular DataFest, which many of you possibly have participated in, and now is run all over the country. And he's a contributor to the blog Citizen Statistician. All right, so now I'll turn it over to Rob so he can tell us about being a statistician versus a data scientist.
Thank you, Kelly. So let me start by saying it's quite an honor to be speaking to such a group of great young researchers. I've had a chance to read some of the abstracts and listen a little bit to some of the talks earlier, and this is a very impressive group. So what I want to talk about today is about this difference between statistics and data science. So I know you're here because of the Undergraduate Statistics Research Conference, and that sort of implies that you're maybe leaning on the side of statistics and maybe even consider yourself to be a statistician. But even if that's true, I'm sure from time to time you've thought about data science. You've wondered if you should call yourself a data scientist. You maybe thought that your future might lead to data science, whether that be in industry or graduate school. So I think it makes sense, and maybe you even already think of yourself as a data scientist. So I think it makes sense then to ask, what is data science and how is it different from statistics? So to begin with, let's just think emotionally. And now, there we go. So quickly and without thinking, I want you to write down the 3 words you first think of when you hear statistician, data scientist. So that's 6 words total. I'll pause for a moment or two so I can pretend that you're actually writing it down. Okay, so I don't have the means to actually gather the words you wrote down, so I'll do the next best thing. I'll turn to Google. So I Googled the words statistician and word cloud together, and here's the first result that came up for me. So take a moment to just kind of take in some of these terms. You see lots of statistical terms: inferential, experiment. I don't know what Century is doing there. Methods, mathematics, confounding. So lots of statistical words. Now let's look and see what happens if you Google data scientist and word cloud. Okay, so the word data comes up. That's not surprising and kind of reassuring in some ways. But what else do you see? People, business, scientist. So my own personal impression is that these words are more business-oriented. They're more about getting work done. They're about professions and careers and about people. And the statistics word cloud was about methods. It was about statistics. So I don't know if this difference is real or meaningful, but I think it points us towards one fact about this difference between data science and statistics, and that's that the difference is partially cultural. And that's what I'm going to be elaborating on today. And by cultural, I mean it's a difference that's due to attitudes and preferences, maybe even generational. So to take this just a little bit further, now that you've thought of some words, I want you to think of some pictures. So what pictures come to mind when you think of a data scientist, and what pictures come to mind when you think of a statistician? And don't worry, I'm not going to ask you to draw anything. So again, Google Images and Google Image Search to the rescue. And on the left side, I should ask you which side, left or right, you think is statisticians. But the left are the statisticians, and the right the data scientists. So I'll leave it to you to decide if you see any big differences there that are worth noting. I'm a little amused by the fact that both groups are associated with whiteboards that seem to be filled with these complex-looking scribbles that I don't think have anything to do with statistics or data science. Maybe a scribble here and there does. But otherwise, I feel we're not getting a really strong signal that tells us about the difference between data science and statistics. So to dig a little deeper, let's look at a slightly more formal definition than the images that come to our mind. And this is now a very famous Venn diagram that I'm sure most, if not all of you, have already seen. It's from Drew Conway, who's a data scientist and founder of the company Alluvium. So his vision of data science is that it sits at the intersection of three domains here. We can quibble about this a little bit, and I'm about to. So for hacking skills, I would substitute computer science. For math and stats knowledge, I'd separate out those two bubbles and have a math bubble separate from a stats bubble, because for me, those are very different domains. It's hard to say, substantive expertise, I'd probably replace with domain knowledge or knowledge of area of application. If you want to see even more quibblings, the internet is just filled with different versions of these Venn diagrams that are all attempting to define data science. I think one common theme, though, that you're going to see in these Venn diagrams is that the notion that data science is a blend of computer science and statistics. So for me, this notion doesn't really distinguish between statistics and data scientists, because most statisticians I know do quite a bit of computation. I don't think you can survive in statistics anymore without doing a fair amount of computation. And there's even a subfield of statistics called computational statistics. So let's go even yet more formal and look at more formal definitions of data science and see if that helps differentiate for us. So the first comes from a journal called the Journal of Data Science. And so with the title like that, you'd expect that the editorial board spent some time thinking about what data science is, and here's their definition. So I'm not going to read the whole thing to you, but data science is collecting, analyzing, modeling. It has almost everything that has something to do with data. Okay, so that's one definition. Let's turn to Wikipedia, why not, for another definition. So data science is an interdisciplinary field about extracting knowledge or insights from data in various forms. Okay, so data science is about knowledge and insight from data. Now, I don't know about you, but to me, that's the way I've always thought about statistics. And I think I'm not alone in this among statisticians, that's not a departure for us from what we thought of as statistics. So again, I feel like we haven't really resolved the issue of what the difference is between statistics and data science. And I think part of the reason for that is I think the differences are more cultural than anything else. And so I want to talk about three cultural differences that I've seen in the literature. The first is about approaches to modeling. So differences between statistics and data science as they approach modeling. The second cultural difference is about an emphasis on what it is that we study. And the third cultural difference is about our approaches to getting work done. So let's talk about the modeling cultures first. So Leo Breiman, in a paper that I recommend you all read if you have not already, talked about two different cultures in statistics in 2001. The predominant culture in statistics is what he calls the data modeling culture. And David Donahoe, in a paper we're about to talk about, kind of renamed this the inference culture, which is, at least it's an easier term to say, so that's what I'll be calling it. So Leo Breiman claimed that our over-reliance on the inference culture was preventing statisticians from tackling many interesting and important problems. It was holding us back. Instead, Breiman wanted statistics to take a greater interest in what he called the algorithmic modeling culture. So if I thought data modeling culture was hard to say, algorithmic modeling culture is even harder. And David Donahoe again renamed this the prediction culture. So basically we're talking about the inference culture versus the prediction culture. I'm not going to go into great details in either one, except I do want to make sure that we're on the same page about what these mean. So first let's talk a little bit about what the inference culture is. So in the inference culture, we're primarily interested in describing nature. And the goal of modeling is to build something using data that serves as a description of nature, as a model of nature. With that model in place, we estimate parameters, and these parameters, again, tell us something about that natural process. And a most common thing it tells us is whether a particular variable plays a role in that process or not. So you've seen many examples, I imagine, of the inference culture. So linear regression, survival analysis, logistic regression, and many more. And these are commonly studied in undergraduate statistics courses. The prediction culture, on the other hand, treats nature as a black box. So in the prediction culture, our primary interest is in predicting future observations. Okay, so the goal is to build this engine that generates data that looks as if it came from nature, without having to be constrained to make sure that the engine looks like nature's engine, or like what we think nature's engine looks like. So examples of models that fit into this are classification and regression trees, random forests, neural networks, support vector machines. Okay, so for example, a predictive modeler would be happy to make predictions about how much money an individual visitor to your website is going to spend, and wouldn't feel obliged to build a model that also accounted for how various psychological mindsets might affect that spending decision. If the prediction of how much was spent comes close to how much was actually spent, that's enough. So the second cultural distinction I want to talk about is this emphasis on where we place our attention. So is your emphasis on developing general methods and on using mathematical principles to better understand and improve methods? Or is your emphasis on finding insight from data? So here's a very famous quote from John Tukey in 1962. His point of view here, I think, is that data analysis was where our emphasis as statisticians should be, but that he felt that belief that statisticians should emphasize data analysis kind of separated him from the mainstream statistics world. That the statistics world was more involved in mathematical statistics than it was in data analysis. I think many would argue that this division still exists, and maybe more so in some departments and some businesses than others, but it's still a real distinction. So this second distinction then is this difference between mathematical statistics, where statisticians tend to lean towards, and data science, where and data analysis, where data scientists tend to lean. The last cultural difference of these three is about the way that work is done. And I'm going to play my hand a little bit here and say I think this is maybe the most interesting difference of the three. It was kind of pointed out to me in a recent paper by David Donahoe that was from his 2015 address to the John Tukey 100th birthday celebration at Princeton. And this is another paper I recommend that you read. You can Google it and find it online. So in this paper, Donahoe pointed out that one of the crucial features that made data science successful is something that's been called the common task framework. And Donahoe described this as the secret sauce behind the success of the predictive modeling culture. So what is the common task framework? So this secret sauce has three ingredients. First, it has a publicly available training data set. Second, it has a group of competitors who are working towards this common goal, and that common goal is to use the training set to make predictions about what the future revealed testing data set is going to show us. And the third ingredient is a scoring referee, and the referee's job is to define what it means for a prediction to come close to the actual eventually revealed data, and in doing that to determine who the winner is. So one interesting side effect of this community task framework is that this community of competitors, by sharing their results and also sharing their progress on this problem, they iterate in small steps and sometimes large steps towards a better solution than any one team might have provided on its own. So even though it's a competition, cooperatively they're coming to a better solution than they could come to on their own. So probably the best known example of this is the Kaggle website. Kaggle offers continuously running common task framework competitions, and they give you plenty of data sets to practice on. And another really interesting and fun feature is a community that shares its ideas and thoughts about what works and what doesn't work and why it does and why it doesn't. So if you join a competition, then you receive a training data set. You then build a model on this training data set that makes predictions about the hidden future to be revealed testing data set. You post your predictions, and then it shares your score, only your score with the rest of the world. So that means you also see other people's scores, and that ability to kind of see where you stand with respect to other kind of goads people on to continue to improve. And in most contests, you're allowed multiple postings, so you can continue to improve your score until the contest ends. So here's just a smattering of some of the contests that are ongoing, at least as of early or late last week. And you can see just a wide variety of fields. The Titanic, let's call that history. I don't know if it is or not, but you see insurance, Allstate claims, medicine, neurology, art. So really, literally, something for everyone here. And this is just the first page of just 1 week of competitions. So another example, as was mentioned in the introduction, is DataFest. And DataFest isn't exactly the Common Task Framework, but it's not exactly not the Common Task Framework either. So it's a contest that I started in 2011 with the help from graduate students and colleagues here at UCLA, and some of those graduate students are now faculty in different institutions and have started the event. And the event is now run by the American Statistical Association and is becoming quite widely spread. As in the Common Task Framework, teams commit to a common goal. Here the goal isn't necessarily prediction, but it's a little more general or vague even. It's to find insight in this one particular large complex data set. I mean, one big difference too is precisely what that goal is left to the teams to decide whether insight involves making predictions or making descriptions or making inferential models. The data come from outside organizations, much as Kaggle's data does. Like the Common Task Framework, a group of judges decide the winner. The way it works, the data are revealed on a Friday night. The teams work all weekend under the same roof to complete their analyses before Sunday afternoon. During the event, there's a roving band of volunteer data professionals, and they come from academics, government, industry. So all over to help out teams on request. So the competitors can ask for help. They also get to learn a little something about what these people's careers are like and how they approach problem solving. So another commonality with the Common Task Framework is I think because the teams are all working under the same roof and they're all asking help from the same group of people, there's a bit of feedback going on that helps the teams kind of iterate. And I venture that each team does better than they would ever do on their own if they weren't all working together in that way. And the result is some pretty dramatically great insight, I think. I think even the students surprise themselves about how much they're able to do working in this environment. So as I said, at the end of the weekend, the teams present to a panel of judges, and they have just 5 minutes to make their case. And that 5 minutes means that a lot of deep thinking has to go into communication, making some really tough decisions about what, out of all the work you've done in the last 48 hours, are the 1 or 2 or 3 things that you really want the judges to hear about. After the presentations, prizes are given for these 3 things: best insight, best visualization, and best use of external data. That last one is a little unusual, I think, but basically it awards a team that finds a data set that wasn't given to them, and that data set enhances the context of the original data set, and so provides a deeper understanding of the problem. So some past DataFests in reverse order. Last year we had data from Ticketmaster. They gave us a number of data files concerning visits to their websites in which people were purchasing tickets to concerts and other events. And they asked for help in understanding what patterns of behavior consumers engage in, if these patterns are partially explained by consumers' relationships with the bands as fans or as scalpers, whether future purchases can be predicted, and what role advertising through Google searching plays in decisions that people make when they visit the website. The year before that, we had Edmunds.com. Edmunds is a web-based car selling website and also rates and evaluates cars. And the task there was somewhat similar to Ticketmaster. The year before was GridPoint. GridPoint is a very different organization than the previous two. GridPoint goes to large retailers or companies that have large structures, and they measure every instance of energy usage that these structures do. And GridPoint's goal is to feed this data back to the customer to help them pinpoint where they're wasting energy and where they can conserve energy. So there's a big challenge here in trying to visualize complex streams that come of data from many different locations to come up with a simple signal to give back to the customers. eHarmony is a dating website. They were interested in how well their current matchups were doing and what students could say about the nature of the matchups and what was working and not working. Kiva.com is a charitable website where you can give microloans to entrepreneurs in developing countries. And finally, the very first DataFest at UCLA was the Los Angeles Police Department. And they challenged the competitors to essentially make a policy recommendation. And the data set they gave was every arrest, a record of every arrest in Los Angeles over a 10-year period, of which there were quite a large number. It was in the many millions, and also several hundred variables to explain these arrests. So if your school doesn't already have a DataFest, and you think this sounds like fun, then one thing you can do is to see if there are other DataFests in your area. So go to amstat.org and search there for the DataFest, and you'll find a list of participating sites. I will acknowledge this list has not yet been updated for this year, but that should happen any day now. I hope, and as new sites join, we'll be updating that list. I should also say, if you have not yet been to the amstat.org website, this is one of many good reasons to go. I think you'll find it a very useful website for your career. If you can't find an ASA DataFest in your area that you can join, then I recommend that you start one. So to do that, what you need to do first is recruit a faculty sponsor. And your sponsor is the one who will actually sign up. And the reason for that is one of the things that makes DataFest fun is that the data aren't revealed until the day the event begins. And to keep the data a secret, the ASA discloses the data just to a faculty member who's responsible then for keeping the secret. And so you need to find and identify that faculty member, and then the rest is up to you and your institution about how you organize the actual event. It may be organized completely by the students, or it may be organized by some combination of the students and the department or other institutions on campus. So to get back and continue talking about this last cultural difference about the way work gets done, and by that I mean a way that's centered kind of on a cooperative competition model. I think this is a very different model from traditional statistics. So, traditionally statistics has been done in a collaborative setting. where the statistician is a team member. Maybe there's several statisticians on the team, but they're team members in a collaborative research endeavor. And the other classic model is the statistician as consultant, who kind of drops into a situation to solve one particular problem that's data-oriented, and then leaves that situation and moves on to the next. But this approach of a community attacking a common problem and sharing their progress, I think has consequences for your own career path. So the old-fashioned model for how you got your career going was you got good grades, you got good letters of recommendation, you networked a bit, and all of that is still really important, so don't neglect your grade. But I think this new model also is a bit more entrepreneurial. So you can join contests. You can, and you have, you've joined this research competition, but you can join Kaggle contests. You can join DataFest. You can create your own portfolio. You have the tools to do your own projects. And so you can show the future employers what you can do. They don't have to tease it out of you through an interview process. You can show them concrete examples of what you can do. And I think this is a real big sea change in how we think about doing our work as data scientists and as statisticians. So to just kind of summarize this, what we've seen so far is I think statistics leans more towards the inferential culture. Data science leans more towards the predictive culture. Statistics leans more towards mathematics, data science more towards data analysis, and statistics leads more towards teamwork and consulting, collaborative work, and data science more towards a competitive cooperation model. I'm being very careful to use words like leans to and tends to, because this is certainly not true of all statisticians, some of whom may fall more in the right-hand column than the left-hand column. It's not even true of all departments. I think our own department, sits quite comfortably in the middle of these two columns. But it is, I think, a good description of the differences in these cultures and how these labels are perceived of people. So it's based on some recent and not so recent writings, mostly by statisticians, I grant you, but I still put forward that these are accurate descriptions of these as cultures of behavior, if not necessarily descriptions of particular people working within these cultures. So finally, in the spirit of entrepreneurialism, I'd like to suggest some data science projects that I encourage you to turn your hands to. So first, we've talked about competitions, and you've already joined one, but join more. I'd love to see more people at DataFest. And like I said, Kaggle is free. You can just join and have fun with it. You don't have to go in with the mindset of winning. Just know that you're going to learn a lot just through the competition. Number two, I'd encourage you to do an analysis on a topic that helps people understand a complex issue. So maybe that's climate change, gun violence, poverty, Pokemon Go. I don't care. If you are interested in it, other people will be too. And you have the means now to self-publish this analysis, even if it's on Facebook or on some version of it on Twitter, whatever you choose. You can do that and put that in your portfolio. Another idea I'd like to see more people doing is to create a tool that helps people collect data and understand a complex issue. So think of what Nike and Fitbit have done with exercise, of giving this tool for people to collect data about themselves. Another example that comes to mind is Nathan Yao, the creator of the Flowing Data blog. So he wrote his dissertation about a tool he created that lets people use Twitter to collect data about themselves. So as you go through your day and you have things you want to collect data on, you send it to Twitter, and he has a tool that helps you pull back that data onto your computer so you can analyze it. I'd also like to encourage you to create a tool that helps people analyze complex data. So I'm thinking here of some of the great things the New York Times has done with its interactive graphics that tackle some pretty complex issues and give people a way of playing what-if scenarios. And now we have tools like the Shiny app within our studio that gives you and people the rest of us who don't maybe have the ability to create these more complex visualizations, gives us some tools to to help other people make sense of our data. The other thing, so data transparency is all the rage these days, but governments, especially local governments, often don't really know what it means to make data transparent. So they'll post PDF files, not really realizing that that doesn't help most of us, or creates quite a bit of work before it can help us. Or they'll create simple summary tables, which doesn't really help us get at more complex questions we want to answer. So volunteer to help your local government. Chances are they're already trying to achieve some level of data transparency and would welcome advice. At least I hope they do. The last bit of advice I'd like to give you is to raise up the next generation. Volunteer to teach high school students to program or to analyze data. So high schools are not doing very much yet on the front of data science, but that's changing. I'm involved in a project that's creating a data science curriculum for high school students. They're using R to analyze data. All those teachers would love to have college students volunteer to come to their classrooms and help out. If you don't know of Hour of Code, I invite you to go to code.org and find out when the next one is. This is a day where people all over the world and students all over the world spend an hour programming. And a lot of schools would love to have volunteers to come and help out with that hour. So, see if you can get involved in teaching programming or data analysis at local schools. So, data science or statistics, what should you choose? Well, so I'm going to wimp out here and say, in the end, it doesn't matter all that much. I mean, I think the arrival of something called data science on the scene has already kind of caused statistics to push its boundaries a bit. And so I think these differences are going to diminish even more. But at the end of the day, I think it's really a question of style. It's a question of culture. And I think, therefore, it's up to you. And it's important to keep in mind that both cultures have the same goal. They're trying to find meaning and find ways to find meaning in data. I would end, though, with a caution. And Mike Driscoll, who's a data scientist who founded the company MetaMarkets, says this: statistics is the grammar of data science and is crucial to making data speak coherently. So I'd caution you to avoid joining any sort of data science endeavor that overlooks or ignores statistics, because if you do, you'll just be incoherent, and I don't want you to be incoherent. So I thank you for listening, and I welcome your attention and any comments you may have about what you see as the difference between statistics and data science, and what career paths you yourselves are interested in. So thank you very much for your time, and I welcome questions.
Great, thanks, Rob. So again, if you have any questions, please type them into the box, and I will read them out to Rob. But I would like to start with a question for you, Rob. So people will talk about data scientists and storytelling and being good at telling a story. Do you feel like there's a different emphasis in how you tell the story of the data if you're a statistician versus a data scientist?
Yeah, that's an interesting question. I mean, I think we can say classically there's a difference. And classically, statisticians were taught not to tell stories. We were taught that the story came from the researcher who collected the data and who we were to work closely with. And we were to work with them to formulate questions that could be parameterized into a statistical model. But I think we've seen more and more examples of statisticians helping to tell stories. I think, again, I mean, the role that a good role a statistician plays there is reining in those stories so they don't become too fantastical, they don't stray too far from what the data can actually support. But I think, I think we see more and more of that, and that's one thing DataFest has shown, is that statisticians really do have the ability, if they let themselves, to find good and interesting stories in data.
Yeah, great. Another question I have is, when you presented the word clouds, business was really large in data science, and I agree that I really tie that in with data science, but then, even that graph was devoid of, domain knowledge, but it doesn't have to be business. So do you feel like the tie to business is just because that's maybe where it came from, or do you think that there's something inherent in data science that's very business oriented?
Yeah, that's a great question. And I mean, for people who want a better answer than you're about to hear, I'd recommend you read David Donahoe's paper again about from the Tukey Centennial. I think what's happening here is data science as a research science hasn't found a footing yet, and I don't know if there are any. There might be, but there are very few PhD programs in data science, and I think that's kind of another way of saying that data science doesn't really live in academics yet. The motivation and the need for all of this has come from the business world, using the term very, very loosely. I think the more narrow definition of the business world likes to call this analytics, but the wider business world that includes industry and the web-based products and all has been the real motivator behind this notion of data science. And I think, again, that there is motion now towards it resting more comfortably in academics, particularly as we've seen more and more bachelor programs. I heard a figure the other day, there are now 250 around the country, and so I think that's a sign that it's beginning to grow into the academy. But we'll look and see when we have more PhD programs in the topic.
Yeah, great. I did not know that number, 250. That's amazing.
Yeah, I just heard that the other day.
Yeah. So, okay, so we have a question from a student. So, if an undergraduate student is interested in graduate school, beginning with Masters of Science in Data Science, would obtaining a degree in data science disadvantage a student from then applying to a doctorate degree in statistics or biostatistics?
Well, I don't think any sort of a master's degree in any field will ever be a disadvantage to applying to statistics or biostatistics. I know in our own department, I mean, we've welcomed students from a variety of different backgrounds because that knowledge that you bring about how statistics is applied in that background is really valuable. So I think, I think a master's in data science would be seen as a plus by most programs. It might mean that you spent the last couple of years focusing on something different from what some of your new PhD colleagues will be focusing on, but you'll have strengths that they won't have as well. So I think that'd be a fine pathway.
Great. Okay, so it doesn't look like we have any more questions, so I'll just thank you again, Rob, for your wonderful talk.
Thank you very much.